Hi all. So in the previous class, we know how to check the consistency, inconsistency, and how to get the solution when it is consistent and no solution when it is inconsistent. So today, the new topic, solution of a system of linear algebraic equation in the form Ax is equal to B. There are two methods. First one, Gauss elimination method. Second one, Gauss-Seidel method. So, Gauss elimination method, so where we are reducing the augmented matrix to upper triangular matrix, then we are finding the values of x and y. Whereas Gauss-Seidel method is, it is an iterative process where the procedure we are repeating until we get the two values are equal. So now, first we'll take up the Gauss elimination method, then we'll see one example. So Gauss elimination method. So let me have an example now. Solve the following system of equations. So first one, solve x plus y plus z is equal to 9, x minus 2y plus 3z is equal to 8, 2x plus y minus z is equal to 3. See now, as I told, this is a system of linear equation. More than one linear equation is called system of linear equation. So now we'll apply Gauss elimination method. So now we'll write the augmented matrix. In the previous class, I explained how to write the augmented matrix. So augmented matrix is a combination of coefficient matrix into constant matrix. So this is called augmented matrix. Now first we'll write the coefficient of the first equation. 1, the coefficient of x is 1, the coefficient of y is 1, the coefficient of z is 1, is 2, the b is 9. In the same way, write down the second equation coefficients. 1 minus 2, 3 is 2, 8. Next, 2, 1 minus 1 is 2, 3. So now we have to use only row operations and we have to reduce to upper triangular matrix. So now what happens? First, R2 changes to R2 minus R1. R3 changes to R3 minus, here 2 is there. So I need to multiply 2 to the row 1. So then only I can make it 0. So next what happens? We'll apply this operation and we'll see how to reduce this matrix. So now what happens? I am not changing R1, I am keeping R1 as it is. I am keeping R1 as it is. Only I am changing R2 as well as R3. So what happens now? 1, 1, 1 is to 9. Then 1 minus 1, 0. Minus 2 minus 1. So minus 3. 3 minus 1, 2. 8 minus 9, minus 1. And now R3 changes to R3 minus 2R1. I should multiply 2 to the row 1. So 2 minus 2, 0. 1 minus 2, minus 1. Minus 1 minus 2, minus 3. Is to 8. 3 minus 9 is minus 6. Next I should make this 0. But I cannot take R1 because 1 will come here. So what I should do now? R3 changes to R3 changes to 3R3 plus R2. So R3 changes to 3R3 plus R2. I am multiplying 3 to the R3. As both are negative sign here, so I am taking plus. So now we'll see what happens now. I'm not changing R1, so write as it is. I'm not changing R2, write as it is. I'm changing R3. So 0 minus 0, 0. Minus 3, minus 3. So what happens now? So this is also 0. Minus 9, minus 2. So that is 11 is to minus 15. So now we reduced the augmented matrix to upper triangular matrix. So now we have to write the equivalent equations. Equivalent system of equations. Equivalent system of equations by reduced matrix now. So now treat this as x and y and z. So what happens? X plus y plus z is equal to 9. So minus 3y because x is 0 now. 2z is equal to minus 1. 11z is equal to minus 15. So now what happens? 3s are 45, just a mistake here. So this becomes 44. And here this also becomes 44. So now from back substitution what happens is z 44 by 11, that is 4 you got. Then take the second equation, minus 3y plus 2z is equal to minus 1. Already you got z, use that in this equation, then you will get y. Minus 3y plus 2 into 4 is equal to minus 1. Minus 3y plus 8 is equal to minus 1. Minus 3y is equal to minus 9. Minus minus goes out. Y is equal to 3. So you got z and you got y. Then take this equation. So what is the equation? X plus y plus z is equal to 9. So x plus y plus z is equal to 9. So you don't know x, you know y, that is 3 plus 4 is equal to 9. So x is equal to 9 minus 7, x is equal to 2. Therefore, required solution is x is equal to 2, y is equal to 3, z is equal to 4 for the given system of equation. So this is how solving the system of equation by Gauss elimination method. So here solve by Gauss elimination. The first we have considered the augmented matrix. Then using row operation we reduced to upper triangular matrix. Then we wrote the equivalent system of equation from the reduced matrix. So by back substitution, we first found out z and we next found out y, then x. So then the required solution for the given system of equation using Gauss elimination method, we got x is equal to 2, y is equal to 3 and z is equal to 4. So this is Gauss elimination method. So then we'll see what exactly the Gauss-Seidel method. So as I told, Gauss-Seidel method is an iterative process. Iterative means procedure is repeating until we get the desired root. Gauss-Seidel method. And one more important thing here, in this method, diagonal element should be dominant. So, if I consider A11x plus A12y plus A13z is equal to B1. A21x plus A22y plus A23z is equal to B2. A31x plus A32y plus A33z is equal to B3. Now this is a system of linear equations. The first thing here, diagonally dominant elements. So in the first equation, comparative other two coefficient, the coefficient of x should be large. In the second equation, the coefficient of y should be large comparatively other two coefficient. In the third equation, the coefficient of z should be large comparatively other two things, and these three diagonal elements should not be 0. So, Gauss-Seidel is an iterative process, and also it should satisfy diagonal elements should be large comparatively other two coefficients present in the equation, and also it should be non-zero. So, later on from the first equation, I will take one problem, then I will explain how to solve this. Now we will consider one equation, then how to write the diagonal dominant. So, using solve system of equations using Gauss-Seidel method. So, 10x plus y plus z is equal to 12. X plus 10y plus z is equal to 12. X plus y plus 10z is equal to 12. So, first you have to observe, in the first equation, is the coefficient of x is large? Yes. The coefficient of x is 10 and remaining are 1. In the second equation, yes. In the third equation, yes. And in this problem, all the diagonal elements are same but need not be same. Now, from the first equation, I should write for x. So, x is equal to, what happens? Bring it to other side, 12 minus y minus z. But 10x is there. If it comes this side, 1 by 10 into 12 minus y minus z. In the same way, for the second equation, we are writing for y. So, 1 by 10 into 12 minus x minus z. In the same way, for the third equation, we are writing for z. 1 by 10, 12 minus x minus y. So, this is how we are rewriting the equation from the given problem. Then, here initial approximation is not given. So, let us choose x naught 0, y naught 0, z naught 0. This is the initial approximation. If the initial approximation given in the problem, you have to consider that, otherwise we have to consider 0. As I told earlier, it is a iterative process, means approximation. Now, we will see first approximation, how it will work. So, first approximation. So, what happens first approximation? You have to consider this. x1 is equal to 1 by 10, 12 minus y naught minus z naught. So, you know all the values. Using the calculator, you can find out as if y naught is 0, z naught is 0. So, 12 by 10, that is you are getting x as 1.2. Then in the same way, y1, you consider the second equation here. 1 by 10 into 12 minus here. instead of x0, you have to consider x1. Recent values you have to use it for the next value. But z1 is not there. Still we are using z0. So substitute the values accordingly and calculate. So you will get it as 1.08. Then z1. So what happens to z1? 1 by 10 into 12. You got x1. Then you got y1. So take the new values to get the next value. So now if you calculate z1, see recent value x1 you have to take 1.2, y1 you have to take 1.08. So what you are getting here 0.972. So as I told, the iterative process, you have to continue second approximation. So what happens to second approximation? So now x2, what happens to x2? 1 by 10 into 12 minus y1 minus we got z value, recent value z1. So accordingly you substitute the values and simplify, you will get 0.9948. y2. 1 by 10 into 12 minus, we got x2 recently, minus we have z1. So 1.0033. z2. 1 by 10, 12 minus x2 minus y2. So 1.0001. So now you should check the values here. See here, x1 you have 1.2, x2 you have 0.99448. So it's not same. y1 is 1.08, y2 is 1.0033. Again it is not same. z2 is 0.972, z2 is 1.0001. See, x1, y1, z1 is not matching to x2, y2, z2. So you have to repeat the procedure until you get two sets of values are equal. So what happens? We are moving with the third approximation and we are checking. If not, we are going to the fourth approximation. Same way, I will write the values. You can try your own using the calculator. So third approximation x3, directly I am writing the same procedure, but directly I am writing the answers 0.9965. y3 1.0002. z3 1.403. So now I can approximately equal to 1. But still this is not the same. Again I am moving to the fourth approximation to check for the exactness of the equation. So fourth approximation, x4 1, y4 you are getting 1, z4 you are getting 1. So now you have to compare x4, y4, z4 with x3, y3, z3, not with x2, y2, z2. Consecutive value should be equal. So now stop the procedure. So therefore required solution is x is equal to 1, y is equal to 1, z is equal to 1. So using Gauss-Seidel method. So the one thing you have to remember, in the Gauss-Seidel method, diagonal element should be dominant and non-zero. So then you have to write it accordingly, then choose the initial approximation and repeat the procedure until you get two roots equal. So this is about Gauss-Seidel method. Thank you.